trying to show the sine of theta plus the cosine times the cotangent is equal to the cosecant. So at least we have some direction. We know that we need this side to look like this side. When we've done these in the past, I've always said work with the side that has more stuff on it. So we're going to obviously work with this side and try to make it look like that side. Going from here to here would be much more complex. So we have sine of theta. Probably don't want to do much with that. I'm going to leave it sine of theta. Plus cosine of theta. Probably don't want to do much with that either. So I'm going to leave that as cosine of theta. And then what does cotangent mean? Cosine over sine. Very nice. So we have cosine of theta over the sine of theta. And we're trying to make it look like this, remember, but I'm not going to write this down now until I've actually made this side look like that side. So can I cancel anything out right now?
No.
We have cosines. Remember, this cosine really means cosine over 1. So
Can you
Cross
when can you
nope, can't cross out the signs because there's a plus sign here. Very good. So I think we just need to clean this up a little bit. We've got the sine of theta plus cosine of theta times the cosine of theta is cosine squared of theta over 1 times the sine of theta is the sine of theta. Remember, you've got a sine of theta here with nothing underneath it, so you can always put it over 1. So what we're doing really is taking a fraction plus a fraction.
times it and
Yep.
flip it?
Yep, cross multiply and then multiply the denominator. So we're going to have sine times sine. Sine squared. And we have 1 times cosine squared. Cosine squared. You should already see what direction that's going. I'm going to come up here because I want to make sure everyone can read my right. Now, when you are cross multiplying, you cross multiply this way and you get sine squared. I'm going to put like a little note over here that sine squared. And then you multiply this way and you get cosine squared. And the reason I'm doing this is because when there's a plus sign in between it, it really doesn't matter which order you add in. But if there is a minus sign in between them, it does matter. So make sure you're always taking what you get over here and write that down first, plus or minus what you get over here. So we end up with sine squared of theta plus cosine squared of theta all over sine of theta. Heather, you asked me something a second ago. Did I answer your question yet?
I was gonna ask. I thought you were supposed to switch it before you times it, but that's for dividing, I guess.
Oh yeah, for dividing. Yep. What is this? You should recognize that.
1.
It's 1. Pythagorean theorem identity. So really, what you have is 1 over the sine of theta. What is 1 over the sine of theta? See, isn't that what we wanted?
Wow, that look is so simple.
So that one wasn't so bad.
These are kind of fun.
I should give you a hard one.
One that you think that would be.
Yeah. Well,
So slick.
let's that is true. That is very true. Let's try this one. Can I erase this?
No. Yes.
I'm going to see if you remember this from yesterday. This did come up yesterday kind of unexpectedly, and we talked about it. We've got cosine of theta over 1 minus the sine of theta. And we are going to try to show that that is equal to the secant of theta plus the tangent of theta. Now this time, it's kind of hard to decide which side you're going to work with because they both have a lot going on. So you might want to start with this side and see if you can make this work. I am going to start with this side. What is this an identity, first of all?
No.
No, because what's missing? Squared. Yep, it would have to be 1 minus sine squared. It doesn't have the squared, so it's not going to work. But does anybody remember what we did with this yesterday?
We
you foiled it.
1 minus 7.
1 plus 7.
Yes, we multiplied the bottom by 1 plus the sine of theta. But if we did that on the bottom of the fraction, we had to do it on the top of the fraction too. So I'm going to multiply by 1 plus the sine of theta on top too. So what we're gonna do, I'm gonna leave the top the way it is right now, just to see if this is gonna get me somewhere. If it doesn't, I may want to then distribute the cosine in, but for now, I'm gonna just stick to what I have right now. Then we gotta multiply the bottom, FOIL the bottom. Now, when you multiply these two things, 1 minus the sine of theta times 1 plus the sine of theta. Some of you are able to recognize that your middle terms are going to just cancel out. But I'm going to do it again for those of you that aren't quite there yet. 1 times 1 is 1. 1 times the sine of theta is the sine of theta. Negative sine of theta times 1 is negative sine of theta. And then negative sine of theta times sine of theta is negative sine squared of theta. They cancel out. You're left with 1 minus sine squared of theta. So I'm going to write that down. 1 minus sine squared theta. So, let me just talk again about what just happened. When I multiply these two things and they look exactly alike, the only difference is that one is a plus and one is a minus. All that really happened was that we multiplied the ones at 1. We multiplied our sine of thetas and got sine squared of theta. That happens when the binomials that you are multiplying are exactly the same except for the plus and the minus sign. I'm going to come up here and finish now. I've got the cosine of theta times 1 plus the sine of theta. What do I have on the bottom? Yep, 1 minus sine squared of theta is actually cosine squared of theta. We have cosine of theta times something over cosine squared. So there is a cosine on top, and there are 2 cosines on the bottom. One of them is going to cancel out. So this one is gone, and I no longer have a 2 there. What I really have is 1 plus the sine of theta over the cosine of theta. Both of these things are over the cosine of theta. If they are both over the same thing, I'm going to separate them. 1 over the cosine of theta plus the sine of theta over the cosine of theta.
Oh.
Well, both of these things, 1 and the sine of theta, are both over this. They're over the same denominator. So I just separated them and I made them 2 separate fractions. Both with the same denominator that they were over. And I did that because I know that 1 over cosine of theta is secant, or excuse me, yeah, secant theta. Is the secant of theta. And I know that the sine of theta over the cosine of theta is actually tangent. Is that what I wanted?
Yeah.
That's what I wanted. Secant of theta plus the tangent of theta. Yes? Should we do one more, or you want to just try some yourself?
Try something and go over it.
Okay. You can stop the video.